The core idea is simple. Don't send every request to your most expensive model. Route by task, risk, and value. Validate the answer. Then escalate only when confidence drops. That is how we balance cost, latency, quality, and reliability. We started by looking at why GenAI systems fail in production: cost spikes, latency, outages, and quality drift. Then we built a controlled inference platform. Now routing becomes the decision layer. It chooses the right model for each request before we plan capacity around that demand. Model routing solves a common trade-off. If every request goes to the strongest model, the platform spends too much on simple work. If every request goes to a small model, quality and reliability suffer. A router adds a decision layer. It looks at the task, risk, context, and sometimes prior failure signals, then chooses the cheapest model likely to succeed. Simple queries can use small or fine-tuned models. General tasks can use mid-sized models. Complex or failed requests escalate to stronger models, preserving quality without making premium inference the default. A tiered model architecture starts with one rule: don't spend intelligence you don't need. If deterministic logic, a template, retrieval, or a cache can answer the request, keep it at tier 0. For predictable, high-volume tasks, use a small tuned model. When the request is ambiguous, complex, or low confidence, escalate to a larger internal model. Save the premium API for rare cases where quality, risk, or failure recovery justifies the cost. The router matches requirements to the cheapest reliable tier, so capability rises only when business value demands it. One of the easiest routing wins is to stop treating every prompt as equal. Classification and tagging usually do not need a frontier model. A small, fine-tuned model or traditional classifier may be enough. Extraction can also stay small when the schema is stable and validation catches errors. Summaries and rewrites are more variable, so route by length, domain, and style requirements. For reasoning or open-ended synthesis, start stronger, or escalate quickly when the cost of a bad answer is high. The goal is to match capability to risk before paying for power. Before routing a request, the system needs a fast way to understand what it is asking for. The classifier gathers cheap signals: metadata, prompt template, user segment, document length, and available context. From those signals, it labels the task family, such as extraction, summarization, rewriting, Q&A, or reasoning. It also estimates complexity, risk, sensitivity, and expected output format. Those labels feed the routing policy, which chooses the right model tier. The key is discipline. The classifier must be inexpensive, observable, and faster than the model call it is guiding. Routing should not end when a model is selected. After the response comes back, the system needs a second decision. Is this answer safe to use, or should it escalate? Treat model confidence as one signal, not the source of truth. Stronger signals come from validation: valid schema, required fields present, acceptable format, citations available, business rules satisfied, and no refusal or contradiction detected. When these checks fail, escalation should happen automatically through policy. That keeps quality decisions consistent, observable, and separate from improvised application logic. Validation gates are where model output becomes production output. Start by checking the contract. Can the response be parsed, and does it match the required format, such as valid JSON or XML, required fields, and correct types? Then check meaning. Is the answer relevant, grounded in the retrieved evidence, free of contradictions, and within policy? Finally, apply business rules such as allowed values, domain limits, customer rules, or compliance requirements. Each gate should produce an explicit decision: accept clean output, repair small defects, retry when needed, escalate uncertain cases, or fail gracefully instead of exposing unreliable content. A tiered fallback workflow should be deliberate, not just try another model. Begin with the lowest cost model that can meet the requirement. Then use validation gates to decide whether the answer is acceptable. If it fails, record why: low quality, timeout, rate limit, system error, safety refusal, or policy issue. Pass that context forward so the next tier does not repeat the same mistake. Also set a hard fallback cap. Without one, retries can quietly create high latency and runaway cost. The goal is controlled escalation, not unlimited rescue. Commercial APIs are not banned in this architecture. They become the exception path. The default request should try the lower-cost self-hosted route first. Premium access is reserved for cases where the business value or risk clearly justifies the spend. Enterprise customers, critical workflows, complex reasoning, or recovery after repeated failures. A healthy pattern might move from 100% API traffic to only 8 to 15% premium usage. The key is governance. Set budgets, quotas, and approval thresholds, then log every invocation with reason codes like complex reasoning, tier 2 underscore timeout, enterprise customer, or validation failed twice. Think of the router as a reliability control plane, not just a traffic cop. Every request carries a latency budget, so per tier timeout stop one slow model from spending it all. Circuit breakers watch for error spikes, out-of-memory events, or degraded latency, then temporarily remove unhealthy pools from rotation. Bulkheads isolate resources, so one failing tier cannot drain capacity from the rest. And when every preferred path is unavailable, graceful degradation keeps the experience alive with a cached answer, partial response, simpler model, or human handoff. The goal is controlled failure, not surprise failure. Routing policy is production logic, so treat it like code. Each version should define the task types, customer segments, model tiers, thresholds, fallbacks, and premium API conditions that control routing decisions. Every request trace and cost record should carry the policy version, so you can explain why a model was chosen and measure the impact. Deployment should be safe, not all at once. Use shadow routing, canaries, and gradual percentage rollouts. If cost, latency, or quality moves the wrong way, roll back to the previous version quickly. Routing needs an audit trail, not just a final answer. For every request, capture the inputs that shape the decision: task type, complexity, customer tier, policy version, and chosen model. When the system falls back, record a reason code, such as timeout, schema failure, low confidence, refusal, or circuit breaker open. Then attribute spend by route, tenant, feature, policy, and task category. Most importantly, monitor latency and quality per route. Global averages can look healthy while one policy version or premium path is quietly regressing. Policy tuning should be treated like product experimentation, not a one-time configuration. First, test candidate policies offline against golden datasets and historical traffic, so obvious regressions never reach users. Then compare versions across the metrics that matter: cost per request, P95 latency, validation pass rate, escalation rate, premium API usage, and human quality scores. Promising policies should move through canaries or A/B tests under real traffic. The goal is not simply cheaper routing. Tune thresholds carefully, because small savings can create hidden quality loss and erode user trust. Model routing is the control layer that makes optimized models work as one serving system. Start each request on the cheapest model that can handle it. Validate the output, check confidence, and escalate only when quality or risk demands it. Treat premium APIs as exceptions and measure every policy change. Those signals become the foundation for auto-scaling and capacity planning next.